Welcome. This video provides a complete overview of the big data ecosystem. We will explore the various tools and technologies that make up this landscape and understand how they work together to process and analyze large volumes of data. Let's start with the data storage layer, which is fundamental to any big data ecosystem. Here we have three key components. First, we have Hadoop Distributed File System, or HDFS. This is a distributed file system designed to store large datasets across clusters of commodity hardware. This makes it highly scalable and fault-tolerant. Next, we have NoSQL databases like MongoDB, Cassandra, and HBase. These databases offer flexible data models, which are suitable for handling unstructured and semi-structured data. Finally, we have cloud storage solutions such as Amazon Simple Storage Service, Azure Blob Storage, and Google Cloud Storage. These services provide scalable and cost-effective storage options in the cloud. Now let's explore batch processing. This involves processing large datasets in batches. We have two prominent frameworks here. First, we have Hadoop MapReduce. This is a traditional batch processing framework that processes large datasets in parallel using map and reduce functions. Here is an example of map and reduce phase. The map phase emits key value pairs, and the reduce phase aggregates these values to produce the final results. Next, we have Apache Spark. This is a fast in-memory processing engine that performs batch processing more efficiently than Hadoop MapReduce. Here is a PySpark code. It reads data from a file, splits it into words, and counts the occurrences of each word using map and reduce by key operations. Let's move on to stream processing. This involves processing data in real time as it arrives. We have three key platforms here. First, we have Apache Kafka. This is a distributed streaming platform that enables you to build real-time data pipelines and streaming applications. Here is a snippet where the producer sends messages to a topic. Next, we have Apache Storm. This is a real-time computation system that processes streaming data with low latency. The code snippet shows how to define a topology with spouts and bolts to process data streams. Finally, we have Apache Flink. This is a unified stream and batch processing framework that provides high throughput and low latency stream processing. The code snippet shows how to create a stream from a socket, split the text, and perform calculations. Now let's look at data analytics and query tools that enable us to analyze and query large datasets. We have two key tools here. First, we have Apache Hive. This allows you to run SQL-like queries on Hadoop data, making it easier to analyze large datasets stored in HDFS. This code block here shows how to create a table and query the data in Hive using SQL. Next, we have Presto, also known as Trino. This is a fast distributed SQL query engine that can query data from various sources including Hive, MySQL, and others. This code block shows how to join data from different sources and perform aggregate queries. Let's delve into machine learning. This enables us to build and deploy machine learning models on big data. We have two key libraries here. First, we have SparkMLib. This is a scalable machine learning library that provides various algorithms for classification, regression, clustering, and more. This code block here shows how to train a logistic regression model using SparkMLib. Next, we have TensorFlow. This is a deep learning framework that allows you to build and train complex neural networks for various machine learning tasks. This code block shows how to define a simple neural network model using TensorFlow's Keras API. Now let's explore data visualization, which is crucial for understanding and communicating insights from big data. Here are three key tools. First, we have Tableau. This is an interactive business intelligence platform that allows you to create real-time dashboards and perform advanced analytics with a drag-and-drop interface. Next, we have Power BI. This is Microsoft's business analytics solution that provides self-service analytics, cloud integration, and mobile access. Finally, we have D3.js. This is a JavaScript library that enables you to create custom interactive charts and web-based visualizations, making it ideal for creating data-driven documents. Now let's discuss resource management. This ensures efficient allocation and management of resources in a big data cluster. We have three key frameworks here. First, we have WRN. This is Hadoop's resource negotiator that manages cluster resources and schedules jobs. It provides resource scheduling, multi-tenancy, and cluster management capabilities. Next, we have Apache Mesos. This is a distributed systems kernel that provides resource abstraction, framework isolation, and fault tolerance. Finally, we have Kubernetes. This is a container orchestration platform that automates the deployment, scaling, and management of containerized applications. Let's explore data ingestion tools, which are used to collect and ingest data from various sources into the big data ecosystem. Here are three prominent tools. First, we have Apache Flume. This is a streaming data collection service that aggregates and delivers log data reliably with its event-driven architecture. Next, we have Apache Scoop. This is a bulk data transfer tool that efficiently transfers data between relational databases and Hadoop with parallel data transfer and incremental import capabilities. Finally, we have Apache NiFi. This is a data flow automation platform that provides a visual interface to design and automate data pipelines with real-time processing and data lineage tracking. Now let's discuss monitoring and governance tools, which are essential for maintaining the health and security of the big data ecosystem. We have three key tools here. First, we have Apache Ambari. This is a Hadoop cluster monitoring tool that provides cluster management, performance monitoring, and service configuration. Next, we have Apache Atlas. This provides data governance and metadata management capabilities, including data lineage tracking and data classification. Finally, we have Apache Ranger. This is a security administration framework that enables you to define access control policies, audit capabilities, and data masking to secure your data. Let's dive into cloud platforms that offer comprehensive big data services. Here are three major cloud providers. First, we have Amazon Web Services (AWS), which provides a wide range of big data services including Elastic MapReduce, or EMR, Redshift, Kinesis, Glue, Simple Storage Service known as S3, and Athena. Next, we have Azure, which is Microsoft Cloud Analytics Platform. It offers services like HD Insight, Synapse, Data Factory, Cosmos DB, and Power BI. Finally, we have Google Cloud, which offers big data services such as BigQuery, Dataflow, Dataproc, Pub or Sub, and cloud storage. So now let's see how the different components of the big data ecosystem integrate to enable a seamless data flow from ingestion to insights. We start with data storage. Here, data is stored in HDFS, S3, and NoSQL databases. The data ingestion tools like Kafka, Flume, and NiFi collect and ingest data from various sources into the storage layer. Next, the data is processed using frameworks like Spark, Storm, and Flink. Analytical tools like Hive, Presto, and mlib analyze the processed data. Finally, the insights are visualized using tools like Tableau, Power BI, and D3JS. This unified ecosystem enables seamless data flow from ingestion to insights. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.